Welcome back. We're going to look at 4.2.1 now, which presents complex numbers. Essentially, what we do with complex numbers is extend the real numbers in a very particular way. We introduce a new, what's called imaginary unit. So this is what's sometimes called I. We introduce the square root of -1. Why would we do this? Well, the point is that I squared plus 1 is equal to 0, according to setting I squared equals, if I set I equals square root of -1, then I squared plus 1 equals 0. In other words, x squared plus 1 equals 0 has plus and minus I as its roots. So introducing complex numbers allows us to solve polynomials that did not have roots when we looked at just real numbers. If you'll recall, x squared plus 1 has no real roots, but it does have complex roots. So complex numbers, in some sense, extend real numbers to give us solutions to so that all polynomials have solutions. In particular, my allusion to the polynomial x squared plus 1 can be made more general in the following sense. If I have a polynomial ax squared plus bx plus c, then the quadratic formula tells me that my roots are given exactly by -b plus or minus square root of b squared minus 4ac over 2a. If this quantity here, b squared minus 4ac, is negative, then I'm going to get something negative under the square root. This is where, again, imaginary constants come into play. This is where I need to have this notion of square root of -1 in order to be able to efficiently and accurately address the problem of having complex roots. Right, so this object here is sometimes called the discriminant. Right, in a mathematical sense, it discriminates between having real roots and complex roots for your polynomial. And I'll just say that a complex number is one that has an imaginary part and a real part. So for example, 1 plus I is complex, 2 minus 7i is complex, plain old 3i with no real part is also complex, but then we also consider the number just 4 to be complex, right? If you have a real part or an imaginary part or both, you're considered complex. So complex numbers in particular include real numbers. So let's look at ways to visualize these numbers. So a common thing to do is to plot complex numbers in what's called the complex plane. So it's somewhat like the Cartesian plane, except instead of having an x-axis, I have what's called a real axis. And instead of having a y-axis, I have what's called an imaginary axis. So I can plot complex numbers by imagining that their real part is an x value and their imaginary part is a y value. This gives a nice visualization for these numbers. So let's look at the first one, 2i. Real part is 0, imaginary part is 2. So it's sitting here. So that's A. B is 2i plus 1. So it is sitting like there. That's B. C is just -7, so 2, 3, 4, 5, 6, 7. It's sitting something like there. D is 4 minus 3i. So we move on the x-axis over to 4 and then down by 3. So there's D. And then finally, E is just -i. So I imagine moving down the imaginary axis by 1 unit. So there is E. This gives a useful representation for where complex points are living relative to one another. Or you can, again, think of the y-axis as corresponding to the imaginary part of your number, and the x-axis is corresponding to the real part of your number.